All right, thanks everyone for joining us here. My name is Ram Narayanan. I'm a managing director at Goldman Sachs. I head up our data platform and solutions engineering teams.
Hi, everyone. Thanks for joining us today. Good evening. My name is Abhishek Narang. I sit in data engineering at GS as well, along with Ram. My day remit is to run any sort of external market data, vendor data hypothesis. So bring it in our governed lakehouse ecosystem, which we're going to learn today.
All right, so today we're going to be talking about our fully interoperable lakehouse with Databricks and Unity Catalog. We'll start a little bit around like why we got to where we got to. Talk a little bit about how we strongly believe Iceberg is the foundation for the future and why we have built our entire lakehouse and data strategy around it. We'll talk about how Databricks powers our lakehouse, including like a very critical component called the refiners that we will delve into and how it's helping us solve that. Some open sharing, like how clients share data with us, which we haven't done really in the past, that Databricks helped us unlock. And then we'll hopefully leave plenty of time for questions. But beginning a little bit with the journey here, right? Like to walk you back in time, it was actually around like the global financial crisis of 2008 when we really realized the power of having all our data in one place. By then, our businesses had grown complex enough where it was no longer feasible to compute important metrics like counterparty risk, how much margin you owe, and you had to do all of this overnight, right? And calculate your exposure to like entities like Lehman. And we realized at that time the power of having all our data in one place together, right? And so we've been like on that journey for the last 15 years or so, or 18 years or so, and different iterations of that. We built our on-prem data lake in like the 20 teens, and that was showing its age, and that's when we needed a new strategy for our data going forward, and that's when we came up with Legend Lakehouse a few years ago, right? A few tenets, none of this should be super surprising to anyone in an enterprise, but something that's unique to like financial services. Goldman Sachs is a large global financial services firm, so being secured and governed with your data is just table stakes, right? Otherwise, no one would use whatever we had to build. But one of the things we learned from previous iterations of what we did was that we really needed our production grade data to also be available for fast experimentation, like for like our analysts and strats and quants who need to be able to experiment, right? And that's something that we really didn't get right with our previous iteration, and that's one thing that we really wanted to focus on this time around. We also wanted to make sure that part of our challenges was that the transparency around cost, especially when you're in a large organization with many, many silos, we had a little bit of a socialist system, right? Like where things weren't being accounted for properly, so it was an important tenet for us to get that right. And then I'll touch a little bit on single sources of truth throughout the presentation here, but like the single biggest challenge in financial services in a large enterprise is that there is copies of data everywhere, right? Because it is far too easy to copy over data and get things done quickly, rather than do the right thing and get it from the source. So we've had to be very innovative around how we share data in a zero copy fashion, and Databricks and Iceberg help enable us that. So we'll talk a little bit about that as well. Anything else you want to mention, Abhishek?
Just experimentation and fast boot up. That's a cornerstone when you're working with our strategists and PMs on quant investment kind of business in Goldman. So that helps us a lot, making sure that we keep it as an upfront tenet.
All right, so skipping ahead, I'll just briefly touch on our reference data architecture. And how it works is that we have things that produce data at Goldman Sachs. We call these points of data entry. These could be your trading systems. It could be like a system that traders mark end of day positions, right? Or it could be any number of systems that generate data. We call these points of data entry. These then flow down to things we call ADSs, or authoritative data sources. The reason we do that is that bilateral data exchange in an enterprise is very, very expensive, right? So if everyone has to go to the producer of the data and get it from there, it just ends up being a very complicated graph of dependencies where things don't quite end up with the right answer. The other challenge with that is that consumers of the data have to know exactly where they need to go to, right? And that can become very complicated and expensive over time. So we landed on this concept called authoritative data sources, which really capture important concepts that Goldman cares about, like trades, risk, margin, reference data, right? And these are available to the entire enterprise via well-defined APIs that we call data models, rich data models that capture the full complexity of the data and its association with other pieces of data, right? And then the next layer is everything that runs on this, right? Like all kinds of applications, whether it's our like BI stack or like our like management reporting or document management, other kinds of like analytics run on top of this like data layer, right? And so we've done like a good job of selling all our businesses that they really need to get their data in shape in one place with well-defined APIs if you want to get true value out of it, right? Now we are on our journey there, and it's not like everything like is in exactly that spot, but we are well along our way to like helping achieve this stack happen. One thing I wanted to touch about again is like I mentioned like having well-defined APIs to access data, right? So for a long time, almost a decade, we've been a big buyer in semantic models for our data, right? Because in financial services, data is not extremely large the way it is in like some other industries, but it is very complicated. The relationship between different types of data is very context specific, and like you need to know how to navigate the graph of data across multiple hops. And the cost of getting something wrong can be very high, right? So you need to be very precise about when someone says, hey, how did you like price a position? You need to know, did you use a clean price or a dirty price, right? Like all of these details matter, and there's like so many nuances around answering a particular question. So it becomes very important for producers of data to have very well-defined models that describe their data with all the surrounding information that we thought was useful a decade ago, so we've been doing it for a while, but now we realize all that investment might pay off because finally we get to like teach our AI models how to understand like these semantic models that have been built over time. And so for the Lakehouse, we came up with this concept called a data product, which is like a evolution of like the data model I mentioned, but it has a bunch of useful things like the description of the data, sample data points, diagrams that like how relate like that show how the data connects to other pieces of data, obviously ownership, what do you need to get access to it within the enterprise, and other things that people might find useful, right? And you do this for every piece of data that you really care about. You tie ownership to it, and you prevent duplication, right? Like you do not have like two sources of OTC derivatives at the firm, right? Because that would lead to bad outcomes. And so this helps us get towards our goal of like having single sources of truth with well-defined data products that are easy for humans and for the AI agents to eventually understand. Moving on, we want to talk a little bit about like what we've done over the last year. We were here last year talking about our journey with Databricks as well. But since then, we've managed to enable nearly all our business units with separate Databricks workspaces that provides like the kind of isolation that they require. Our Lakehouse is built on Iceberg, right? I talked about it earlier. We strongly believe in like Iceberg as the metadata format that has won the format wars, and it is going to like be the foundation on which we base our Lakehouse. We strongly believe in interoperability, right? Like, and we have like great partners like Databricks who truly believe in that concept as well. And so, like, we've given our entire Lakehouse data, which is like Iceberg on top of S3. Databricks has access to that layer, and obviously it's done in a controlled way. We have our standard entitlements mechanism, authorization mechanisms applied to our Databricks usage of that data. And we have all kinds of like control monitoring that help us get comfortable with using this data, with this highly sensitive data in that ecosystem. Talking a little bit about Iceberg, I don't feel I need to like preach this to this crowd, but literally it is like something that's going to help us achieve our dream of like zero copy data and true interoperability across engines, right? And this is very important to us because we feel that like different engines are going to be better at different workloads, and our businesses like deserve the choice of like trying out different engines for different workloads. We also like really do not want our data copied from one place to the other when we want to use different engines, and so Iceberg really helps us get to that end goal, right? A few things here that we have been working on over the last year is like Iceberg V3 now has support for variants. That was like a big gap for us because we could only do so much without the variant data type. And this unlocks a whole range of possibilities for us. And so we had a few hiccups, like, in making it actually go into production, but variant was a game changer in Iceberg V3. And also, like deletion vectors for faster row-level operations, nanosecond timestamps. There's a whole bunch of really nice features coming up in V3 that we really like. And I'm happy to say that our entire plant is now Iceberg, right? Like all our data on our lakehouse is fully on Iceberg. It wasn't the case when we spoke here last year. And we talked about how we do not allow direct physical access to the data, right? We have data models which we layer on top of like the Iceberg governance layer. So like when a consumer accesses a piece of data, it always goes through that semantic data model. And I mean, obviously, like we use Unity Catalog because it gives us like some really good features like the zero copy interoperability. We get to have like a uniform governance layer, which we previously did not have, and like the kind of optimization features you can unlock, right, using Unity Catalog instead of like the previous mechanisms to do it, like really help us get things like lineage, access controls. These are very important for us, and that's how we landed on this. I am going to now hand it over to Abhishek to talk about refiners.
Great, thank you, Ram. So at the heart of it, Goldman Sachs Lakehouse ecosystem is a massive ELT machine. Where we have unlocked a massive use case on that is the transformation part of our data and how we are leveraging Databricks for that. So the whole idea is the data for bunch of data sets has been materialized in an Iceberg. All your parquets have been materialized in an Iceberg format. They are in our own S3 buckets. Databricks can read that data, understand that data. UC has the right permissioning scheme that we have orchestrated on it. And then we can express a logic to transform the data and then ingest it back into our Lakehouse ecosystem as a derived data asset. We can transform through SQL, Spark, like choose your favorite poison. The whole idea there is we focus on, back to the Lakehouse tenant that we were talking about, going as serverless as possible. Like you don't want your banking and markets personals to kind of look at provisioning the clusters during market open and market close when the whole world is going frantically crazy on the SpaceX allocation. So that's the idea of like where serverless kind of really helps you out. Centralized governance, you do want, if it's your MNPI deal in banking, you do want a tighter need-to-know entitlements control on that data, and you do want to make sure that it's segregated. To Ram's earlier point, every BU, every business unit in Goldman is kind of having its own workspace. How we quickly, breezing through this, how we deploy is we use Databricks Asset Bundle, where we have orchestrated our own inbuilt, homegrown deployment service, where a customer of our data, let's say an analyst or a portfolio manager or a sales engineer, they come in, they can scribble a very simple Databricks Asset Bundle YAML, in which they'll talk about this is the identity I am, this is the workspace I want to write to, this is the data, and this is the software family kit I belong to. We call it deployment in Goldman. That's all. They just give us that. Rest of the orchestration is all taken care of by Lakehouse infrastructure that GS has created here. We already talked about serverless. Whether it's like zero infra play, like you don't want your strategists and quants to kind of chaperone provisioning of the clusters or looking at the Spark jobs, which they are taking care of fixing all the knobs. So that's one idea. Auto scaling, we talked about whether it's kind of trading spikes end of day. You do want the system to take care of it in auto flexing. Reliability and security. Well, you do want all of this data orchestration in your ELT machine to be well governed, well authored, well defined, and well owned. So the whole idea is different workspaces which carry different workloads from different business units in Goldman can have their need-to-know entitlements enforced. Okay, where we are in the journey. We are migrating 4,000 and change refiners from our on-prem system where we were previously onto a Databricks orchestrated gigantic GS Lakehouse ecosystem. In that, like, there are a bunch of capabilities that we have used AI. Like, we don't want all our strats and engineers and data scientists to do the repetitive, repetitive work. So AI takes care of the heavy lifting of that, where engineers are just looking at the exceptions, just the breaks. We went through a massive Spark upgrade from, you would just laugh at it, like Enshit 1.x is the version where we were, with very little testing there. But then first thing we did was we used AI to first beef up all the functional tests on our existing code base, then used AI to migrate that to the latest and greatest version of Spark. That helped us a lot. That's the test generation and validation, really we could score using this AI accelerated migration tooling. So Ram did mention, like, we are a user of delta sharing, now called as open sharing. So one of the areas of Unity that really shines for us is if we are in a certain region, in a certain deployment, which happens to be same as where our clients are, then we can leverage delta sharing approaches to get that data from our client in our compute. The data still remains in our client deployment. We are adding value-added enrichment on that data in our global banking and markets business, and then we can create a derived data product that our client can get access to. So this kind of a zero copy sharing without any replication, without any brittle need to write reconciliation framework on like data on both sides if you start copying is really, really terrifically useful for us. It also improves trust in the shared data because all your permissioning is still orchestrated by a single source of security truth, which is sitting in UC, in Unity Catalog. So we, in our world, Ram mentioned that we use Legend as a data modeling and data orchestration paradigm in Goldman, which is also open source to Finos. All the entitlement rules, all the access rights on that data, all bridge from that single source of truth. And then we use UC to enforce it in this kind of a paradigm. We have a demo for you today. While I go to the demo, any questions for us so far?
Go ahead.
What were the trade-offs then when you chose Iceberg versus other models?
Yeah, I think the question is what were the trade-offs when we chose Iceberg versus like other options that we may have had. I think like from the very beginning we saw like the vision in Iceberg, right? Like the concept of being able to query more efficiently than like previous like paradigms that like like the Hive, for example, right? Like it just was like a lot smarter than like it did things a lot smarter than like we're previously done. I think that was one big part of it. The fact that like there was just like a lot of momentum in the community that like people quickly gravitated towards it just made it a lot easier for us, right? I think that was like the single biggest point. The fact that we were able to then convince our partners like Databricks to add like more value add-on features that helped us use Iceberg just like sealed the deal for us. But I think it was really the momentum and like the gravitation of like the market towards Iceberg, and it's proven to be like the right choice if you ask me.
Yeah, when we were previously on an engine managed table storages, really like there were a bunch of things that were likable, right? Like you like the latency because it'll be fastest because that engine is taking care of their storages. It'll be like governance, etc. Though the moment we saw that community pull towards in Iceberg, you can have all these features and latency going almost at par with the engine managed storage, with everybody backing it. Interop is something that we really love, right? Like you don't want to be logged into vendor A or vendor B's, their own roadmaps or features, and all the attributes or functionalities that we needed. We talked about variant, that was one of the important features. We talked about, deletion vectors for soft deleting the rows, to increase the velocity, how you're doing the DML operations. As soon as those things started coming in, we were all in, right? Like, why wouldn't we like an interop?
I mean, the single biggest reason was like our allergic reaction to copying over data, right? We were copying data all over the place, and that leads to bad outcomes, right? If you're like native format, and you want to use different engines for different like features that they offer, you just have to copy the data over, and that's just like operationally in the long run, it leads to bad outcomes.
Yeah. Okay, let's look at the demo. All right. Okay, give me 1 second. Yeah. Okay, so what we're going to show you today is yes. Yeah. We are building a pipeline that would show you that we are ingesting two important data sets. One is the Magnificent 7 stock prices, and the other is the Fed fund rates. Now, the reason of choosing these two is that there is an inherent relationship between these two data sets. If I'm playing a role of, let's say, a Goldman Sachs equity research analyst, I do want to understand what is that relationship. If the Fed rate hikes, how does it pressure kind of growth or tech names? If it goes down, does it lift the valuation? So that is the kind of investment regime analysis that you would try to do your thesis to figure out the price targets. So for the purpose of this demo, what we have done is we have created this Python-based notebook infrastructure in which we have created I paused it for a second. So we've created a bunch of GS data engineering skills to operate on our lakehouse. The operations could be identifying these data structures, reading data from the foreign catalog, ingesting your data as a Iceberg format back to your lakehouse, and a bunch of other things. So first things first, what we're going to do is we're going to look at those two data sets, the prices and the Fed funds, which have been already materialized into our S3 volumes as a governed Iceberg data set by a foreign engine. So here what we'll do is we'll create a federated connection. So that's what is being done. And on that federated connection, we created a foreign federated catalog. In that catalog, there are two tables which are already existing. And we're going to zoom in on the T part of ETL, how we are looking at those data sets, transforming them, and creating a valuable derived assets. So when we look at this particular one, the one where the cursor is, this is the managed catalog in Databricks, in Unity, which has views existing on top of tables which are present in the foreign catalog, which is the one which says 325963 SFDB, right? So that's how the setup has been done. That your already ingredient data source are there, and you have created a managed catalog on the objects in that foreign catalog. We're showing you some information schema meta commands. So this guy talks about that in your foreign catalog, the way we have set up our managed catalog is it only has access to that particular S3 volumes and the coarse grain control on the objects there. Then if we look at the schemas in that foreign catalog, it's going to show you a bunch of schemas. The one for the purpose of this demo that we are interested in is this DBX Summit trading data. That's the schema we are talking about today. Coming back to the demo, first things first, we're going to authenticate ourselves. Okay. The second thing we're going to do is we will initialize what we call as a Databricks client in our SDK. The initiation of SDK needs a few arguments from the end user. Which workspace does the end user want to connect to? In this case, DataEng-PP is that workspace. The second is which application software kit family does it belong to? So that's the owning did 325963. And we're going to take this prompt and using our GS data engineering skills for Lakehouse, we're going to use Copilot agent mode to create a code for this. So again, to recap, with just 2-3 arguments, we are able to instantiate a particular Databricks client for this current session. So that means our session is tied to now that client. The second thing we're going to do is we deploy a refiner job. Refiner as in the transformation semantic that we want to bring into those two data sets that we talked about earlier. So going to the notebook here, first things we will look at is our code. What exactly is our transformer code going to do? So this is that Python code. It's very simple for the purpose of the demo. We're going to look at our Magnificent 7 tickers, get the data for those tickers from the already ingested pricing data by the other engine. We're also going to look at the second data set, which is the Fed fund rates, which is again, it's already present in our S3 as a governed Iceberg table. And we're going to do some wrangling on top of data. This is the Databricks asset bundle that a user of this ecosystem has to pass in. Again, only a couple of attributes that this will pass in. What is the workspace? What's the software family, deployment family that you want to use to package your software, as well as that you want to use the task type as Spark Python task, and your Python code is that refiner showcase.python. So pretty much this is all that the customer of Lakehouse and Goldman has to do. Internally, when we deploy this job, we use our own written deployment server, which will take this Databricks asset bundle YAML and fleshes it out to many other facets. See, the thing is, when we are refining this data, transforming the data, one of the things we have to know is whether the ingredient data sets is right now ready for consumption. It's a batch mode. We're talking about an OLAP system here. So the first things first is whether it's ready for consumption. So there are like, states that we leave on our ingredient data just to depict that. Here we are showing you that particular fleshed out YAML that we have created, which talks about, okay, where is this ingredient data sitting? Where is the target location for that data? There is a concept that we have coined internally, we call it watermark, which simply is the state of the current batch which has not been consumed yet on the ingredient data set. Okay, so the deployment has happened, and it's going to return you that job ID, that deployment ID. Next thing is we're going to now run this deployed job. Again, we'll use our Lakehouse, GS Lakehouse skills. And there are just two things that this particular prompt needs. One is availability URN, like where is your source data sets and the digital signature of all the coordinates. And the other is target URN, which is like, where do you want to push it? The entire signature and the coordinates of this is where I want to push it, this is how I want to entitle it. So those are just the two things that it's going to use to run this job and then ingest the derived data set back into Lakehouse. When I run it, it's going to emit a bunch of logs. So first thing it did was, the first thing was the availability URN. The second is it's trying to fetch what is the Lakehouse location where I want to write it. This is the one where availability one. The second is the where I want to write it. So that's the right location one. And the third thing is it's going to kick off that refiner job, which we go to Databricks notebook and we can see whether that refiner job has come in action. We use serverless compute. So what we're showing here is it takes just a couple of seconds to kind of instantiate, and we're using the performance optimized serverless compute for our purpose. So which is something that we like. And now that particular job is running. It's going to take a minute and a half sort of a thing to complete. But while it runs and starts emitting application log, let's come back. We have a polling endpoint at this point, which will keep polling what's the current status of that particular job. So based on the job ID, that endpoint will just keep checking the health of that particular Databricks job. It has started emitting these application logs. So at this point, if you just, it's pretty deep, but like, the two data sets that we were talking about, the equity prices and the financial Fed rates indicator, those are the ones that it has read that it has to consume batch one of those. So that's the watermark that was available, not yet to be consumed. It has consumed it, and it is applying that Python logic to transform that data. So that's the piece that it is going on. It continues to poll. The job at this point has completed. So now the transformation has happened. It has created that derived data set at this point. And we're calling that as EQ fed analysis as your derived data set. What it will do is it will try to find from that target URN that we passed, okay, which is the S3 volume location where you have to persist this particular parquet back. So now we are making the GS Lakehouse ecosystem aware that a new derived data set has been persisted back to that S3 volume, the staging bucket that we call it. And from there, it gets ingested back into Lakehouse as an Iceberg table. Again, so what we have ended up doing here is 5,000 odd records have been appended to that table. We can go to a Databricks console, go to the notebook, and we can try to see that for the batch ID 5, can we navigate to the correct path, and can we look at whether we have indeed inserted 5,208 record here. So basically what has happened is it's the full circle. We have consumed ingredient data sets on prices and Fed rates. We have understood the data, we have orchestrated the right entitlements, we set up the Spark code to transform that data, and the derived data asset has been ingested back into the Lakehouse. So that is the step where we have reached. Ram talked about data product as one of the concepts that we have come up with in our Lakehouse ecosystem, which is a concept that you can cluster contextually related data sets together. It has a well-defined owner, it has a description, it has the relationships encoded in our private semantic layer in such a way that you don't have to reverse engineer those relationships looking at the schema. So now what we're doing is for this particular data set, like what we have inserted, we have created a data product already with all this rich metadata. We're trying in this Python notebook to import that data product and just look at just the live rows, the latest active rows from that data product. Why it's important for some of our strategist users, data scientists, data engineers is they don't want to leave their current playing sandboxy environment. So if they're on Python, they just don't want to leave here and go to, let's say, a Databricks console or some other place. So the entire piece is orchestrated here with like a GS Lakehouse, a bunch of skills. Apologies for this rendering. But anyway, the next thing we want to do is doing a bunch of data sciencey analysis on this data. So you have that data product. Let's say I want to look at some window function based on ticker and date, what has been the count of XYZ kind of prices or on that data that we have in the system. Let's say I want to look at some overlapping ranges for the Fed rates and prices. So you can do your basic data sciencey task on these data sets. Next thing we want to just quickly showcase here is what is the causality relationship between the prices and the Fed funds. So the way we want to do it here is the first chart says, okay, you have these magnificent 7 tech names and you have the different prices for the last year's worth of data. Then let's just plot them as is. The second thing we want to do here is plot them with a baseline of 100. That way you can compare how they have rallied or not in tandem with each other. So that's that was the whole idea. That periods where one stock rallies while the others lag, you can easily note that. The widespread in the price level across tickers can be easily noted. Next chart is about Fed rates. Again, at a baseline, how do you kind of understand it? So when the Fed rates are raised, the borrowing cost will increase across the board, and then it'll put the downward pressure on your equities. So here the Fed cut rates, the cheaper capital tends to boost the equity. So that will be clear in the next chart, but this is basically your Fed rates graph, which is going to show you that what's the staircase pattern here, what has happened in the recent past. Here the chart 3 will bring them together, and you will be able to look at the inverse correlation. The places where you did not see the inverse correlation is all the AI-driven revenue boost and that rally, which is like April-May timeframe, but otherwise you can clearly see that with the sensitivity of these growth tech names against the Fed rates is clearly evident here. Yeah, that pretty much kind of wraps up our demo.